welcome to True Projects. In this video, we are going to explain about the project that is intrusion detection in IoT and IIoT, comparing lightweight machine learning techniques using TON IoT, WSTL IIoT 2021, and Edge IIoT set datasets. So, before getting into the execution, first let us understand what is the project about. So, today, almost everything around us is connected. Factories they run on smartphones, that is smart machines. Hospitals rely on connected medical devices, and even energy grids and transportation systems that depend on IoT and also IIoT devices to function smoothly. So this kind of connectivity makes life easier and industries more efficient because data flows instantly and decisions are made faster and process can run almost on their own. But here there is another side to this story. The more devices that are connected, the more chances there are for attackers to break in. Think about it. If even one device is hacked, it can become the doorway to the entire system. That's exactly what has happened in the past. The Mirai botnet attack turned thousands of IoT devices into weapons for massive internet disruptions. Stuxnet managed to damage nuclear systems, and Triton even went after safety controls in the industries. So these examples show how dangerous things can get, not just stealing information, but shutting down critical operations or even causing real physical harm. So while IoT and IIoT are driving progress in every sector, they are also opening doors to serious security risks. This is why finding better ways to protect these systems is no longer just important, it is urgent. And we do have some traditional methods, but most of the traditional intrusion detection systems they work like an antivirus. They look for known patterns or signatures of attacks. The problem is attackers are constantly coming up with the new methods. So these systems they fail when faced with something they haven't seen before. So here where machine learning models comes in. Instead of just relying on fixed database of signatures, ML based ideas can learn patterns of normal behavior and also spot unusual activity even if it is brand's new type of attack. This makes them far more powerful in detecting unknown or evolving threats. And moreover, but deploying ML based ideas in real IoT environments isn't that simple. One issue with that is the data sets used for training. In the datasets like TON IoT, WSTL IIoT 2021, and Edge IIoT set, the number of normal traffic samples is far higher than the normal type of attack samples. This imbalance makes it harder for models to correctly identify rare attacks without producing lot of false information. So another problem is with the limited resources of IIoT devices. Many of them don't have the processing power or memory to run heavy machine learning models. So, even if a complex model performs well in theory, it may not be practically to deploy on, that is, it may not be practically applied to deploy on small devices in the real world. And the another last issue is with a generalization. A model trained on data set that is, it may be TON, IoT, or any other data set might not work well on the another data set because network behaviors and the attack patterns vary across the environments. So, this makes it challenging to build a single model that can handle different IoT scenarios effectively. So, all these challenges point to one thing: there is real need for lightweight, efficient, and generalizable machine learning based idea solutions that can work well with the imbalanced data run on limited devices and still detect attacks accurately. So here, the project, that is the proposed system, is a lightweight intrusion detection system built using machine learning, specifically designed for IoT and IIoT environments. Since many IIoT devices have limited processing power and memory, the system is optimized to run efficiently under these resource constraints while still being able to detect different types of cyber attacks. To make sure it works well on real world conditions, the system is trained and evaluated using three well known benchmark datasets that are TON IoT, WS, that is WUSTL IIoT 2021, and Edge IIoT datasets. So these datasets cover different IoT, that is IIoT scenarios, network conditions, and attack types, allowing the system to learn and generalize better. By focusing on the efficiency and adaptability, the system aims to provide strong security without overloading IIoT devices. To deal with the challenges of working with large and imbalanced data sets, two techniques are used. The first technique is chi-square feature selection. So this helps to pick out the most important features from the data set, and this reduces the number of unnecessary inputs, lower computational cost, and makes the model more efficient. Second, because adapt samples are much fewer compared to the normal traffic in IIoT datasets, we have incorporated synthetic minority oversampling technique, that is SMOTE. It creates additional synthetic samples of the minority attack classes, balancing the dataset. So this helps the machine learning models to learn better patterns of rare attacks, leading to more accurate and reliable intrusion detection. And the system sets several supervised machine learning models to find the most effective way to detect the intrusions. So this involves decision tree, that is DT, random forest, and ensemble techniques such as bagging, stacking, and light GBM to determine which models are both accurate and also practical for IIoT devices. The performance is measured using precision, recall, accuracy, and FN score, which show how well attacks are detected. So this is what we have proposed in this project. And moving on to the extension part, to further improve the accuracy of the project, to further improve the performance, this project incorporates voting classifier model, which combines several strong machine learning models, that is boosted decision tree, bagging with random forest, and XGBoost. So by combining these models, the system becomes more accurate and reliable in detecting intrusions, as each model's strengths help cover the weakness of the others. And here, to make the system's decisions understandable, explainable AI techniques have been incorporated, that are LIME and SHAP. So these methods show which features were the most important in making predictions, helping us users and also security analysts understand why the system flagged certain traffics as malicious. And here, front-end interface has been developed. So additionally, a front-end interface is developed using Flask that allows users to easily enter the data and also see predictions on a simple dashboard to ensure security and privacy. User authentication is also added, making the system safe to use while allowing practical testing in the scenarios. So this is the that is the extension part. Now moving on to the flow of work. To implement this project, we have followed the steps which are mentioned in the flow of work. So these are the steps which are followed in this project. So now let's understand how we have implemented this project. So first we have imported all the necessary Python libraries and packages to handle data processing, model building, visualization, and building the front end. Then comes exploring the data set. So here in the step, the data sets are examined to understand their structure, size, features, and the types of attacks present. So these are the three data sets used in this project. Then comes pre-processing. So here we eliminate missing data entries, avoid repeated records that can bias the model, and remove abnormal data points that may skew learning, and also keep only relevant features for model training. And then comes data visualization. So here, visual techniques are used to understand the data set. First, the correlation matrix. It shows the relationship between features. And the next one is sample outcome, which display a few records to understand feature values and target classes. Then comes label encoding. So here in the step, categorical data is converted into numerical forms so that machine learning models can process it. Then comes feature selection. So here we have used select k-best with the chi-square. So this selects the most important features that strongly influence the target, reducing complexity and improving efficiency. Then comes resampling the data. So here we have used smooth technique that generates a synthetic samples for minority data classes. And here we have also used random undersampler, which reduces majority class samples to balance the data set. And in the next step, the data set is split into X features and Y target. So X, that means features are assigned to the X label and target label is assigned to the Y. Then the data set is split into train and test, where training set is used to train the model and testing set is used to evaluate the model on unseen data. And then we will be initiating models, and then we will be training the machine learning models to learn the patterns for detecting the intrusions. Then we evaluate those codes using, we evaluate all the machine learning models using accuracy, precision, recall, and FN score. And those scores are visually represented through graphs for the comparison purpose. Then the best performing model will be saved for the future use. And coming to this XAI part, so here we have used Lyman Chap, which explains the features that contributed most to the model predictions, which improves the transparency and also trust in the system. And coming to the front end, we have developed front end with the Flash framework, including registration and also login with the SQLite database. So here a user-friendly interface is created for interacting with the system with the authentication for secure access. And in the front end, users, they will be giving the input features that will be pre-processed at the backend. It will be fed with a train model, and train model will be giving us the prediction. So this is how we have implemented the project. And these are the algorithms used. These are the algorithms used for prediction. And moving on to the requirements to implement this project, basically we need hardware and software requirements. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And in software, we need application of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is all about the abstract. Now let's move on to the implementation. So to execute, we are supposed to open the code folder that contains source code files. So let's open it. These are the source code files. So let's understand each of them. The first folder is the dataset folder. So these are the different files of Edge IIoT dataset. And in this model folder, we have the algorithm information that will be loaded into the project code during runtime. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And this is the templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the test cases folder. So let's open it. So here we will be doing prediction for all the three data sets that we have used. And this is the TON IIoT dataset. So these are the different files. And here this is the WUSTL IIoT 2021 dataset. So here this is the original dataset. And after pre-processing, we have stored it into this file. And we will be training models on this process data. And this is the app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have notebook files. So these are the Jupyter notebook files which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. So here, in this Jupyter notebook file, we will be loading this data set, we will be pre-processing the data set, and we will be training the models on this data set for prediction attacks of this data set. Similarly, the TON IoT and WSTL IIoT. And this is the signup.db file, which is the database file used to store the user information. So this is all about the code folder. Now let's execute it. So copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open Anaconda prompt. So it is open. Now give the command cd, give the space, paste the copied path, click on enter. Here you can observe that current directory is changed to the code folders path. Now compile app.py file. So type the command python space app.py and now click on enter. So this command, it will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and port. So now copy this local link provided by the Flask framework and paste it into any web browser. I have copied it. I prefer Google Chrome, so I will paste it in that. So paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So you can see, right? Now we need to get signed up first. So click on sign up. and enter all the registration details if you have not created the account. So I have already created the account. I will directly sign in. Click on sign in. Give your username and the password. Now click on sign in. We have signed in successfully, and here we are redirected to prediction page of the project. Now let's do prediction. So here we will be doing prediction for all the three data sets. So let's do prediction for the first data set, that is Edge IIoT. So click on that. Here, so you can observe 15 parameters. So these are the 15 parameters that we are supposed to give as input for predicting the attack. Let's understand each of them. So the first one we have is the frame time. It is a timestamp of when the network packet was captured, and it helps in analyzing traffic patterns over the time. Then we have HTTP content length. It is the size in bytes of the HTTP message body, which is useful for detecting unusually large or small payloads that may indicate attacks. Then we have TCP ACK. It is the acknowledgement number in a TCP packet. It indicates which data byte have been successfully received by the other side. And then we have TCP ACK raw. It is a raw acknowledgement number before normalization or processing, often used for detailed TCP flow analysis. Then we have TCP DST port. It is a destination port of the TCP packet which identifies the service or the application the packet is directed to. Then we have TCP len, that is the length of the TCP segment, that is excluding headers. It helps in detecting anomalies in the packet sizes. Then we have TCP sequence. It is a TCP sequence number which tracks the order of the bytes in a TCP connection for proper data reconstruction. Then we have TCP SRC port. It is the source port of the TCP packet, identifies the originating service or the application. Then we have MQTT protoname. It is the protocol name in MQTT packets, usually MQTT. It helps to verify protocol usage in the IoT communication. Then we have MQT topic. It is a topic to which an MQTT message is published or subscribed, important for analyzing message routing and topic-based attacks. Then we have MQTT topic length. It is the length of the MQTT topic string, which can help to detect abnormal or malicious topic names. Then we have MQTT var. It is the version of MQTT protocol that may be 3.1, 3.1.1, etc. Useful for compatibility checks and detecting outdated or vulnerable devices. And then we have MBTCP length. It is the length of the Modbus TCP packet, which is useful for detecting unusual message sizes in the industrial networks. Then we have MBTCP trans ID. It is a transaction identifier in Modbus TCP communication, which helps to track request response pairs. And then the last one we have is MBTCP unit ID, that is underscore ID. This is the identifier of Modbus unit device. The packet is intended for important for device specific analysis and anomaly detection. So this is all about the parameters. Let's enter them. For that, we're supposed to open the test cases. Open the test cases. As we're doing prediction for Edge IIoT, let's open this. It's opening, just wait. So here we have the files. So here are different test cases that we're supposed to give as input. So now let's apply filter to this because this we will be predicting. So first let's check with the class 0. So I'm applying filter to class 0. And now let's enter this test case. So your frame time, it is 107. It is some change. And then we have HTTP content length is 0. And then we have TCP acknowledgement, that is 2951. I'm entering it. And then we have TCP acknowledgement raw. So paste it. And then we have TCP destination port, that is 443. TCP length is 12. TCP sequence is 1005. And then we have TCP SRC port that is 60092, and rest all values are 0. So now let's enter all values as 0. We came to the end. So now click on submit inputs. So this given information, it will be pre-processed at the backend and then it will be fed it to the train model. Then that train model will be giving us the prediction. So just wait for a while. It is being processed at the backend. So here we got the result. So it is predicting that the attack type is DDoS ICMP. So this is the about attack, that is ICMP based distributed denial of service attacks, flood that target with ICMP packets overwhelming network resources. So this is about the DDoS ICMP, and here are the recommendations. That means it is telling block ICMP traffic from suspicious sources and also monitor network traffic for unusual spikes. So this is about DDoS ICMP prediction. Now let's check with the other class. So let's check with the class 1. Click on OK. And now click on Home and Edge IoT. So now let's check with this case. Copy the frame time, HTTP length, that is 0, TCP acknowledgement, that is 1548, and then we have TCP acknowledgement, that is 3.783E, that will be converted into number. Then we have destination D port, TCP length, and then TCP sequence, that is 467324, TCP protocol, that is 443, and the other values are 0. So let's enter all the other values as 0. We came to the end. So click on submit inputs. Here we got the prediction. It is predicting that it is DDoS TCP attack. And about the attack, it is telling that TCP based DDoS attacks exploit the TCP protocol to exhaust server resources and disrupt services. And this is the recommendation. That is, it is recommending that to implement SYN cookies and to use firewalls and to monitor for abnormal TCP connection attempts. So let's predict again with the other class. So now let's check with the class 0, sorry, class 2. And now let's check with the first case. So copy the frame time. And the TCP, that is HTTP content length is 0. And TCP, well, just a minute. So here TCP acknowledgement is 3348. Then we have TCP acknowledgement raw. And then we have TCP destination port. Then we have TCP length, that is 1300. TCP sequence, that is 129.37529. And then we have TCP SRC port, that is 433. Sorry, that is 443. And the all other values are 0. So let's enter them. We have entered the last parameter. Now click on submit inputs. So just wait for a while. And here we got the prediction. So here DDoS UDP attack has been predicted. And it is UDP based DDoS attack. It sends large number of UDP packets to random ports, causing the target to become unreachable. And it is recommending that to block unnecessary UDP ports and also use rate limiting to mitigate attack impact. So this is about DDoS UDP attack. Now let's predict the other type of attack. Apply filter to it. So let's check with this case. Here frame time, copy the frame time and paste it. Then we have HTTP length as 0. Then we have 4328 as TCP acknowledgement. TCP acknowledgement raw, that is 1797E. Destination port is 60148. TCP length is 371. TCP sequence, copy it, paste it, and then we have TCP SRC port. So paste that one, and then the other values are 0. So let's enter them as zeros. So we have reached the last parameter. Now click on submit inputs. Here we got the prediction that it is a password attack. Password attack, it attempts to gain unauthorized access by guessing or cracking user passwords. So this is password attack, and it is recommending that to enforce strong password policies and also enable account lockout after repeated failed attempts. So this is about the password attack. Now let's check with the other class. Let's check with the class 4, apply filter. Now click on predict again. So now let's try with this case. Copy the frame time, paste it, then copy the HTTP content that is 0, acknowledgement that is 6487, and then we have TCP acknowledgement raw, TCP destination port that is 60094, and then we have TCP length that is 1280, TCP sequence 629265, and then TCP SRC port that is 433, that is 443, and all the values are 0. So enter them. Now click on submit inputs. So here we got the prediction that it is port scanning type of attack, and that port scanning attack identifies open ports and services available on a network device. And here this system is recommending us to use intrusion detection systems and block IPS that perform aggressive scanning. So this is all about the port scanning. Now let's check with the other type of attack, that is class 5. Click on OK. Click on predict again. Let's enter the values. So let's enter them. Frame time. So I have entered all the parameters. Now click on submit the input. Here we got the prediction that it is ransomware attack. And ransomware, it encrypts files and demands payments for decryption keys. So to mitigate this, we are supposed to maintain regular backups and also avoid opening suspicious email attachments or the links. So this is about ransomware. Now let's check with the other one. So now let's check with class 6. That is the last attack for this data set. So let's enter the parameters. So click on submit inputs. Here we got the prediction that it is vulnerability scanner. And that vulnerability scanner, it is probe systems for known weaknesses to exploit. And here it recommends to regularly update software and patch vulnerabilities promptly. So this is about Edge IoT dataset. Now let's check with the TON IoT. So click on that. So here also we have 15 parameters that we are supposed to give as input for the prediction. So let's understand what are these. The first one we have is the SRC port. It is the source port of the connection indicating the originating service or the application. And then we have destination port. So this is the destination port. It is the destination port of the connection showing which service or the application the packet is directed to. Then we have duration. It is the total time of the network connection or session. It helps to identify unusually long or short sessions that may indicate attacks. Then we have SRC bytes that are source bytes. It is the total number of bytes sent from the source during the connection. It can reveal abnormal traffic volume. And then we have DST bytes. So these are the total number of bytes received by the destination, useful for spotting data, exfiltration, or flooding attacks. Then we have constate. It is the state of the connection, indicates normal or unusual attack behavior. Then we have missed bytes. It is a number of bytes lost or not acknowledged. High values may indicate network issues or attacks. Then we have SRC packets. So these are the number of packets sent from the source. It helps to detect unusually high packet counts typical in DOS attacks. Then we have SRC IP bytes. It is a total byte sent by the source IP across multiple connections, useful for identifying heavy or suspicious users. Then we have DSC packets. It is the number of packets received by the destination and it can highlight abnormal traffic patterns. Then we have DST IP bytes. So these are the total bytes received by the destination IP, which helps to track data flow and potential misuse. Then we have DNS queue class. It is a class of the DNS query, which is important for identifying unusual DNS activity. Then we have DNS queue type. It is a type of DNS query which helps to detect abnormal queries that may indicate DNS attacks. Then we have HTTP response body length. It is the size of the HTTP response body in bytes and it can indicate abnormal or malicious payloads. The last one is the HTTP status code. It is the HTTP response code useful for spotting abnormal or failed requests that may indicate scanning or attacks. So this is all about the TON IoT parameters. Now let's enter the samples of that. I mean test cases of that. Let's open the data set. So here we have multiple parameters that we're supposed to give as input. So let's apply filter to the output variable that we will be predicting. Here we have total 10 different classes. Let's try with the class 0 first. So click on 0 and then click on OK. And here we can see the parameters, right? So these we are supposed to give as the inputs. So here source port is 4948468. And then we have destination port as 80 it is. And then we have duration that is 0.00148. And then we have SRC bytes as 0, destination byte 0, const state as 1, missed bytes as 0, SRC packets we have it as 1, SRC IP bytes are 48, destination packets are 1, destination IP bytes are 40, and then we have it as 0, and here we have all of the values as 0. Now click on submit input. Here also the given input, it will be pre-processed at the backend. It will be fed with a train model and train model will be giving us the attack type. Just wait for a while. So here we got the prediction that it is backdoor attack. And a backdoor attack is a method of bypassing normal authentication to gain unauthorized access to a system. So this is about backdoor attack. And to mitigate this, we can regularly scan for unusual accounts and processes and keep systems patched. So this is about backdoor attack. Now let's check with the other type of class. So now let's check with the class 1. Click on OK. And now we can try with any of the case. So let's try with this one where we have SRC port as 39045 and destination port is 80. Duration, let's copy it. That is 0.00145. And then we have source bytes as 0, destination bytes as 0, and 7 is the const state. Missed bytes are, here we have it as 0. So here we have missed bytes 0, 2, 112, 1, and we have 60, 60, and all of the values are 0. Now click on submit. Here we got the output that it is DDoS attack. So DDoS attack is distributed denial of service attack, flood, a target with traffic from multiple sources causing service disruption. And this is the recommendation that is telling us to mitigate from this DDoS attack. Now let's check with the other class. So let's check with the class 2. Apply filter to it. Click on predict again. So here, let's check with this case where SRC port value is 66, destination port is also 66, and duration is 0.002. Copy it. And then we have source bytes as 0, destination bytes are also 0, common state is 1, 0, 1, 40. And here we have again 1, 40, and the all other values are 0. Click on submit inputs. Here we got the prediction that it is DOS attack. That is denial of service attack, where attacks overwhelm a system with requests, making it vulnerable to legitimate users. So to mitigate this, we can implement rate limiting and monitor for unusual request patterns. So this is about DOS attack. Now let's check with the other class, that is class 3. Apply filter to it. Click on OK. And let's fill with this case and enter the parameters. So SRC port is 47728. Evenly, we will be entering all of the values. So here I have entered all the values. Now click on submit inputs. So here we got the prediction. It is the injection attack. An injection attack inserts malicious code into a program, often via input fields, to manipulate or access the data. And here it is recommending us to validate and sanitize all user inputs to prevent code injection. So this is all about the injection type of attack. Now let's check with the class 4. Apply filter to class 4. And now click on predict again. So let's check with the first case where source port is 49863. Accordingly, we will be entering all the inputs. So here I have entered all the values. Now click on submit inputs. Here we got the prediction. So it is predicting it as MITM attack. That is man in the middle attack. So it is the attack that intercepts and possibly after the communication between two parties without their knowledge. So it is recommending that to use encryption, that is HTTPs, VPNs, and avoid unsecured networks. It is about MITM. Now let's check with the class 5. Apply filter to class 5 and uncheck with the other two classes. Here we have applied filter. Now click on predict again. And here, let's check with this input. That is this test case. So we have source port is 60294. Destination port is 53. And the duration is 0.0057. Similarly, we will be entering all other values. So here I have entered all the values. Now click on submit inputs. Here we got the prediction. So we got that it is normal. That means there is no attack in this case. So no attack detected. The network activity appears normal. Continue monitoring for the suspicious activity. So now let's check with the class 5. Apply filter to class 6. Click on OK. Now let's try with this case. Click on predict again. So select source port, copy it. Accordingly, enter all the values. I will be entering them. So here I have entered all the values. Now click on submit input. So here we got the prediction that it is password attack. And password attack attempts to gain unauthorized access by guessing or cracking user passwords. So to mitigate this, we have to enforce strong password policies and enable account lockout after repeated failed attempts. So this is about password attack. Now let's check with the other type of attack, that is class 7. Apply filter to it. Click on OK. And click on predict again. Let's enter all the values. So let's check with this case. So copy the SRC port, destination port, that is 445. Duration is 0. The next values are 0 up to destination packets. So let's enter the zeros up to destination packets. It is 1. Destination packet is 1. 52 is the IP addresses and DNS queue class is 0. And all the values are 0. Let's enter them. Now click on submit inputs. So here we got the prediction as ransomware attack, and it is about the ransomware attack. And here are the measures to mitigate the ransomware attack. And now let's check with the class 8. So apply filter to class 8. Click on OK. And now click on predict again. So now let's check with this case where SRC port is 49500. Destination port is 1068. And copy the duration value. Copy it, paste it, and the SRC bytes are 0. Destination bytes are 0. constant is 1, missed bytes are 0, 1, 44, and then we have 1, 40, and the all other values are zeros. Click on submit inputs. So here we got the prediction of that it is scanning attack. So class 8 refers to scanning attack and it is predicting the given case to be a scanning attack. And this is about the scanning attack and these are the mitigations for that scanning attack. Now let's check with the other class, that is the last class 9. Click on OK. So now let's check with this case. So copy the source port, that is 54792. Destination port, it is 53. Then we have duration, copy the duration. SRC bytes are 74, 90, 10, 0. So the next value is 0. Copy it. 0, 2. SRC packets are 2. Sorry, that is 130. Destination packet. So that is 2. 146. 1. 1. 0. 0. And now click on submit inputs. Now let's see what will be predicted. So here we got the prediction that it is XSS attack, that is cross-site scripting. And this is about the XSS attack. And here are the mitigation measures. So this is all about the TO and IoT dataset. Now let's check with the last dataset. That is, let's do prediction for the last dataset. So click on the dataset link. So here are the parameters for the last dataset. So let us understand. The first one is S port. It is a source port used by the sender application in the connection. And then we have D port. So this is a D port. It is a destination port used by the receiving application or the service. Then we have DST bytes. So these are the number of bytes transferred to the destination. And then we have SRC bytes. So these are the number of bytes transferred from the source. And then we have taught bytes. So these are the total number of bytes exchanged, that is source boards plus the DST boards, that is DST bytes. And then we have SRC load. It is a data load, that is a traffic volume generated by the source. Then we have DST load. It is a data load, traffic volume handled by the destination. Then we have load. It is the overall load of the connection that is combined. Then we have SRC rate. It is the transmission rate of the source, that is bytes, sender or packets, and the second. And then we have DST rate. It is the transmission rate of the destination. Then we have rate. It is the overall data transfer rate for the connection. Then we have DIPID, that is the identifier of the destination IP, often used to distinguish sessions. Then we have S app bytes. It is the application layer bytes sent by the source. Then we have DAP bytes. So these are the application layer bytes sent in the destination. Then we have total app byte. This is the total application layer bytes exchanged between source and the destination. So this is all about the parameters. Now let's enter the values. Open the test case file. So here it is open. So these are the inputs that we are supposed to give. So now let's apply filter to the class 0. So apply filter to class 0, click on OK. And now these are the inputs to be given. Let's enter the inputs one by one. So here port is 33 444 and the D port is 45. And then let's enter all the values in the similar way. Let's copy and paste it. Destination bytes, source bytes, taught bytes, SRC load, destination load, and then SRC rate, destination rate, DIPID, source app byte, tapp byte, top app byte. So here we have entered it wrongly. So just let's enter them again. And now click on submit input. So here we got the prediction that it is backdoor attack, and it is about the backdoor attack. And here we have recommendation for that attack. Now let's check with the other class. So apply filter to class 1. Click on predict again. Click on OK. So now let's check with this case. So let's enter the values. Copy this port. Similarly, we will be entering all the values. So here I have entered all the values. Now click on submit inputs. Here we got the prediction. So it is com injection attack. That is command injection attack. And this is about the command injection attack. And here are the recommendations for that. Now let's check with the other class, that is class 2. Apply filter to it. Click on OK. And click on predict again. So now let's check with this value. That is this case where sport value is 47349. Destination port is 80, 0, 124, 124. Accordingly, I will be entering all the values. Here I have entered all the values. Now click on submit input. And here we got the prediction, that is DOS attack. And it is about DOS attack. And here we have recommendation for that. Now let's check with the class 3. So let's enter this case. Let's start entering. So here I have entered all the parameters. Now click on submit inputs. Here we got the prediction that it is reconnaissance type of attack. Now let's check with the last class, that is class 4. Click on OK. Now let's check with this case. I will be entering all the values. So here I have entered all the values for the class 4. Now click on submit input. So here we got the prediction that it is normal. So there is no attack with this case. And it is about the attack. And here we have the recommendation. So this is how we need to do the prediction. We are done with the prediction now. Let's check the graphs. So click on about, and in about, let's check with the graphs of first data set that we have built the models. So here we have first one is the sample outcome graph. Here on x-axis, we have all the variables. That is all the outcomes that we have predicted. And on y-axis, we have count of each one. And it shows the class distribution. So this is the sample outcome. And here we have heat map, which shows the correlations between each variable. And this is the confusion matrix. And here we have SHAP value, which shows the importance of each parameter. Here we have SHAP waterfall plot, accuracy score. On x-axis, we have all the algorithms that we have trained, and on y-axis, we have accuracy. This is FN score. Accordingly, we have recall and precision score. Now, let's check with the graphs for the second data set. So this is the sample outcome graph, heat map, confusion matrix, SHAP value, SHAP waterfall, accuracy. Accordingly, we have FN score, recall, and precision. Now let's check with the graphs of the last data set, that is WSTL IIoT. We have click prediction. So let's check with the graphs again. So this is the sample outcome graph, heat map, confusion matrix, SHAP value, SHAP waterfall plot, accuracy, and we have FN score, recall, and precision. Now click on logout. So in this way, just by giving inputs to the application will be predicting which type of attack it is. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.